In this video, we'll go over the problem where you're to write the augmented matrix of the system and use the matrix method to solve the system. But for this one, if you notice on the right, the system of equations, we have x plus y plus z equals to 230. We have x minus 2y equals to 0. 2x plus 3y plus 5z equals to 670. And 2x minus y plus z equals to 230. So we actually have four equations, although we only have three unknowns, the variables x, y, and z. So how do you do this type of a system using an augmented matrix? Well, the first thing we're going to do is to write the augmented matrix for the system. Now, since we do have four equations, then we're going to have four rows to the equations. But we still only have three variables and the constant terms, so there will only be four columns. Like we'll have the first three columns will be the coefficients for the variables, and the last column will be the constants. So in this case, we'd have, let's see, so the first row we have what? X plus y plus z equals to 230. So we'd have the row 1, 1, 1, 230. Then for the second equation, we have x minus 2y equals to 0. So we'd have 1, negative 2. And then when you don't have a z term, you would put in a 0 for it because it would be 0 times z. And then the constant is 0. Then we have 2x plus 3y plus 5z equals to 670. So we have 2, 3, 5, 670. And then for the last one, we have 2x minus y plus z equals to 230. So we have 2, negative 1, 1, 230. So that's our augmented matrix for the system of equations. So again, we have four rows because we have four equations. And now we want to get this into triangular form. So we still would want zeros below the main diagonal. So we'd have want this to be a 0, like we'd have this 1 here, want everything below it to be 0 if we can. And then, well, let's do that first. So the first thing is looking at the first column. So we have this 1 here in the row 1, column 1 position. But we want everything below it to be a 0. Now, since that's a 1, then we could easily figure out what do we have to multiply row 1 by, so that when we add it to the other rows, the numbers below become 0. So for the second row, what we do is to row 2, we just add negative 1 times row 1, which is just the same thing as subtracting row 1. And that'll be our new row 2. And then for the row 3, let's see, so we have a 2 there. So we'd multiply the first row by all of it by negative 2, added to the third row. So we'd have row 3 minus 2 times row 1, and that'll be our new row 3. And then it would be the same thing for row 4, that we have that 2 in the fourth row, first column position. So we multiply the entire first row again by negative 2. So we'd have row 4, that's going to be, we're going to subtract from that 2 times row 1, and that'll be our new row 4. Let's do this work on the side. So let's see, so row 2, which was that 1, negative 2, 0, 0. We're going to add to it negative 1 times row 1. So negative 1 times row 1, that would be negative 1, negative 1, negative 1, negative 230. So our new row 2, let's see, add those together, what, 1 plus negative 1, that would be 0, of course. Then we have what, negative 3, negative 1, negative 230. So, well, first I could have just written our row 1, because that'll still just be the 1, 1, 1, 230. Our new row 2, that'll be 0, negative 2, negative 1, negative 230. Now let's see, for row 3, we're going to take our previous row 3, which was at 2, 3, 5, 670, and add to it negative 2 times row 1. Well, negative 2 times row 1, that'd be negative 2, negative 2, negative 2, negative 460. So adding those together, we get what? 0, 1, 3, 210. So that'd be 0, 1, 3, 3, 210. That'll be our new row 3. Now for row 4, that'll be take row 4, which was at 2, negative 1, 1, 230. Add to it negative 2 times row 1. So that'll be again that negative 2, negative 2, negative 2, negative 460. So we get, when we add those together, we go with 0, negative 3, negative 1, negative 230. So that's our new, let's see. Oh wait, going back, I made a slight mistake here. When I added the first row plus negative 1 times the, or the second row plus negative 1 times the first row, that should have been a 3 there. So it should have been 0, negative 3, negative 1, negative 230. Because that's the same thing it turns out we get for the fourth row, which is 0, negative 3, negative 1, negative 230. Sorry about that. One thing, I wish I could say I did that on purpose, but again, make sure to do things carefully, because again, one little thing like that, just that one little mistake can throw everything off. So being careful of that. Okay, so we got the 1 there in the first row, first column position, 0 is everything below it. Now it'd be nice if in the second row, second column position, if that was a 1. Now it's a negative 3 for right now. But what I can do is I can switch that row 2 and row 3, because this is a 1 in that second column position. So I could just switch, like I said, row 2 and row 3, and that'll make the 1 in the row 2, column 2 position a 1. So I could do that real quick. Let me just do that. So switching row 2 and row 3. So we have 1, 1, 1, 230, and that'll be 0, 1, 3, 210. And we have a 0, negative 3, negative 1, negative 230, and 0, negative 3, negative 1, negative 230. And one thing to note is the last two rows. If you notice that they're exactly the same thing, right? They're both 0, negative 3, negative 1, negative 230. So what I can do is I could just add to row 4, or I could subtract row 3 from that, right? And when you get that, that would be my new row 4. If I subtract row 3 from row 4, well, everything will cancel, so you'll just get all zeros in the last row. So 1, 1, 1, 230, 0, 1, 3, 210, and 0, negative 3, negative 1, negative 230, and then 0, 0, 0, 0. So what it turns out is that that last one, it makes it so it's not really necessary, that the solution from just from the first 3 would be the same thing as the solution from using all 4. That's the thing, when you have 3 equations, if you have 3 unknowns, then you really only need 3 equations. But what we had to do is, we can't just throw away one of the equations. We had to make sure that we didn't end up, for instance, with a row where it's all zeros for the first one except the last number is a non-zero. Now if you remember, when you have that situation, that actually tells you you have no solution to the system, because if you rewrite it as an equation, you get like 0 equals to something non-zero. You end up with a false statement, and that's again an indication you have the no solution case. So we do have to go through these steps. You can't just, like I said, throw away one of the equations. But for this example, this tells us, okay, we really just have to worry about these ones, because again, the last one's just a row of all zeros now. Now all we need to really do is we need to get the element in the third row, second column position, this negative 3, we want that to be a 0. So to do that, we can use row 2, we can multiply row 2 by an appropriate number so that when we add it to row 3, that becomes a 0. And what we will want to do is to row 3, we're going to add to it 3 times row 2, and that'll be our new row 3. Now one thing, let's bring it down a little. So my first 2 rows I'm going to leave alone, 1, 1, 1, 230, 0, 1, 3, 210. And let's see, to row 3, which was at 0, -3, -1, -230, we're going to add to it 3 times row 2. Well, 3 times row 2, that's what? 0, 3, 9, 630. So if we add those two together, we'd have what? 0, 0, 8, 400. So that'll be our new row 3. So 0, 0, 8, 400. And then again 0, 0, 0, 0. So now this is in triangular form because everything below that main diagonal is a 0. So you could keep going, get this 8 to be a 1, and you could do that by multiplying row 3 by 1/8. But what I often do once I get it in triangular form is I rewrite it as a system of equations. So we have what? X plus y plus z is equal to 230. Then we have y plus 3z is equal to 210. And then from the third row, we have what? 8z equals to 400. Now, if 8z is equal to 400, divide both sides by 8, you get z equals to 50. Once we know z is 50, plug that into the second equation. We have what? Y plus 3 times 50, so y plus 150 is equal to 210. Solve for y by subtracting 150 from both sides. We get y equals to 60. Once we know y is 60, z is 50, plug those into the first equation. We have x plus 60 plus 50 equals to 230. So 60 plus 50, that's 110. So we have x plus 110 equals to 230. Subtract the 110 from both sides, you get x equals to 120. So our solution in this case is the order triple 120, 60, 50. So saying x is 120, y is 60, z equals to 50. And remember, with systems of equations, if you end up with a one solution, you could always verify your solution by plugging in those values into the variables into each equation, and it'll satisfy all the equations, which means when you plug them in, the left side will equal to the right side. You won't get one number equal to a different number. So that's the solution for that system.